it's me Chiku from Chiku Study Corner. Today we'll be dealing with the chapter 9 of Physics Class 12 CBSE, that is Ray Optics and Optical Instruments. That is the first chapter of the second textbook. So, over here, first before we begin the chapter, let's talk about something that is very important, our eyesight. Isn't it very important? The source of knowledge. Without eyesight, you can't read, you can't write, you can't do anything. Even there are people who are doing that with much of their effort. But if they had their sight, they would have done it even better. So sight is something that helps you gain knowledge, which helps you do your work, because that helps you moving. It's actually because if you can't see what's there, you can't move. Sight is something very important, because without sight, we might fall into dangers. What helps sight? Is eyes only required for sight? No. Light. Light is the source of what? Of something that we can see. Whatever we see, whatever color or whatever object we see emits light, and that light falls on our eyes. So, let's take a condition. If I hold a pen and if the light falls and comes back and falls to your eye, only you can see this object. In case if there was a hand and you cannot see the pen because the light is not falling on it directly, and nor does it reach your eyes. So what is that? Light is something that is very essential to pull on our lives. So in this chapter we'll be dealing with light. Okay? That too, we have learned in our lower classes what light is: a particle as well as a wave that is called as dual nature of light. Am I right? What all does a light act as? Light act as a particle as well as what? A wave. The particle nature of the light is called as ray optics, and the wave nature is wave optics. In this chapter we will be dealing with ray optics. By the way, what is optics? Optics is a branch of physics that deals with the propagation, the production and nature of light. So what is optics? The definition of optics is what? It's a branch of physics that deals with three things. What are they? The nature of light, the propagation of light, and the production of light. Okay, these are the three factors which are coming under what? The term optics. Okay, as told, wave optics is also called as what? Physical optics. Okay, as well as the particle nature is known as, or ray optics is also called as geometrical optics. What is that? Geometrical optics. Okay, I hope this is clear. So, our dual nature of light, our character is light, and light has a lot of principles, and each principles are explained by different theories. There are a lot of theories that say about light, because one theory cannot prove everything together, and therefore different theories are put forth, and some postulates or some points in every theory would prove some or the other properties of light. So let's see what all are the 7 properties of light. 7 properties are, we will just listing down the properties. We will be dealing about all of them in detail later. So these 7 properties. The first one is rectilinear propagation of light. Second one is a common phenomenon called as reflection. The third one is refraction. Fourth one is interference. Fifth one is polarization. Sixth one is diffraction. And the seventh one is coloration. Okay, these are the 7 properties of light. So, now before we get into detail or into depth about what light is, first, what are we dealing over here? Ray optics. What is ray optics? The particulate nature of light. Also, it's called as what? Geometrical optics. So, in this first thing, what we have to learn in this chapter is the term ray. And then, what all are the optical instruments? We have lenses, mirrors and prisms to learn. Also, our human eye is also an optical instrument. So, let's see what is ray first. So, we have learned about ray optics in our lower classes. Haven't we? We have learned about the definition for a ray also. So, a definition for ray is an arrow mark that represents what? The direction of propagation of light, or what do you say? It's a representation of the path of light. Okay, so what? Path of light. So, to say light is a bunch of rays. Okay, bunch in the sense it's infinite number of rays forms a light. So, this is a ray. This is a light. So, we learned about rays. There are two types of rays that we have to learn. So, let's see what are the two types of rays. So, rays are classified into two, that is divergent rays and convergent rays. So, if you talk about divergent rays, what do you mean by the word diverge? It means to move out, to move away. That is the meaning of diverge. So, divergent rays are rays that either originate from a single point or what they seem to originate from a single point. Okay, you say you diverge to like all four directions. That is, you diverge from this position to all four directions. So, what is a diverging ray? So, if this is the point, this is a diverging ray, or it can be something like this also. This can be a diverging ray. What happens to here? What is happening over here? This is assumed to be starting from this point. Am I right? It's assumed. We have nothing is sure, but we assume that it starts from this point. This can be a divergent ray. Now to talk about a convergent ray, what would be a convergent ray if divergent ray is a ray that diverges from a point or appears to diverge, or they have a originating point from which they diverge. So what would be a convergent ray? Convergent rays or converging means what? Coming to a single point. Diverging means moving out to different directions. So converging means from that directions coming to a single point. So converging rays are rays which appear to converge or they are actually converging. They seems like or they are actually converging. So what will be the difference in this diagram? We will change the arrowheads. Yeah. And let's see what's converging rays. So this would be a converging ray. Okay. This would be a converging ray. So what is a converging ray? Converging ray is a ray, or it's a type of ray where it seems to or actually converges to a particular point. So we learned about ray. Now the next term that we have to learn is beam. So what is beam? We have always said it's a beam of light. A beam of light is traveling. So what is a beam? Beam is what? It's a combination of many rays. Or that is actually a beam means you can say it's a beam of light. That is some number of rays, actually light rays coming together to form beam. So this is actually a beam. Beam is number of light rays combining together. Light rays combining together forms a beam. Okay, so that is what is a beam. So now we've learned about what is a ray. We know what is optics. So we defined what is ray optics in two parts. Now we said this is all about light and the nature of light, how light moves, the particulate nature of light is related to ray optics, etc. So now let's see what happens to light when they hit an interface. So let's see. There are some, properties or some phenomena that actually happen. So let's see how a light behaves. So the next point is behavior of light. Note down its behavior of light. So let's see. What is the behavior of light? We've always learned about something known as rectilinear propagation of light. What is rectilinear propagation of light? We know light always travels in a straight line. In our lower classes, when we learned about reflections, refractions, etc., how did we draw lines? We drew straight lines. Or did we draw something like this? Was this the light ray? No, we always said it's a straight line. So what is rectilinear propagation? That sounds very, tiring, but it's actually simply this. That is, light travels in a straight line. Okay. So, how can you prove that? We have done many experiments to know that light travels in a straight line in our smaller classes. So, the first behavior as told is rectilinear propagation of light. So, when we discussed about the properties of light, we discussed 7 properties. Out of the 7 properties, rectilinear propagation of light, reflection and refraction is explained by ray optics. Okay, the rest of them are explained by wave optics. Which are the rest of them? Interference, then color vision, we had diffraction, polarization, all of them constituted or they were explained by wave optics. So, the second one that we have to learn is reflection. This is a common phenomenon. We all know about reflection. We dealt with what is reflection from our standard 9. So what is reflection? Bouncing back of light. So what happens? Reflection is what? It is when it is hitting a surface, what happens? It will get reflected back. It is like this, okay? It will hit a surface and will get reflected back. So this is called as reflection. So you see, this is our, let's take our surface is, obviously we use a mirror usually. So let's take a mirror. So when this light comes and hits on the mirror, is there a change in medium? Yes. So is this, ray going into the next medium? No. What happens is reflection is a phenomenon that happens in the same medium. There is no change in medium. So what is that? It is in the same medium. Okay. And as told, reflection is the bouncing back of light when it hits a surface. Okay. So that is reflection. So always reflection happens, or there are some laws for everything. Everything has some laws or rules. So over here we have the laws of reflection. So actually these laws of reflection are actually mere observations which have been experimented or observed for many times in many of the experiments of reflection and has proved to be the same in all those. And that is why they are the laws of reflection. So let's see what's the laws of reflection. So we have 2 laws to be learned. So let's see what all are the 2 laws. Laws of reflection. So let's first draw how a ray would come and hit on a surface and would get reflected back. So let's draw this as a surface. To here, a ray comes and falls. and then what happens? This ray is reflected. And what is that? The perpendicular drawn from the point at which the light hits is known as the normal. So this is the normal. This is the reflecting surface. This is the incidence ray. This is the reflected ray. This is angle of incidence and this is angle of reflection. Okay, I hope this is clear. And this point, okay, this point is called as the point of incidence. Okay, the point of incidence. Okay, we have defined we've elaborated or labeled the diagram. Now let's see the laws. So the first law is that what happens when reflection takes place, the incident ray, the normal and the reflected ray, all three would lie in the same plane. What is that? The incidence ray, the reflected ray and normal. What is that? All three lie in the same plane. So this is our first law. I hope that is clear. It's obviously like that because see, this is our reflecting surface. When light ray falls, it will hit and it will go back to the same plane. It won't hit and won't come like this. Instead, it will hit and go this way. Okay? So this rule or this is the first law. The second law is the angle of incidence is equal to angle of reflection. So what is angle of incidence? That is the angle between the normal and the incident ray. This angle is the angle of incidence. So what is angle of reflection? That is the angle between the reflected ray and the normal is called as the angle of reflection. So what is the second law? The second law is what? Angle of incidence is equal to angle of reflection. This is always true. Okay? I told you through observation only we have found out these laws. Okay? So this is the talk about reflection. That is the second nature or second behavior of light when it changes an interface. Let's see the next one. So the next one is refraction. So when we dealt with the very first behavior of light, what did we say? That was rectilinear propagation of light. So I told you that is where a light ray would travel in a straight line. That there is a condition that when it is in a single medium, if there is no medium change, in the same medium it will move in a straight line. Okay? So let's see what is refraction. So we have learned about refraction also in our previous or our lower classes. So what was refraction? Refraction is the bending of light ray when change in a medium happens. So let's take, we have to define the diagram to get a more better understanding. So let's see, this is the medium 1 and this is medium 2. Okay, so what happens? Light ray falls and this is our normal. What happens? This light ray would either be like this or would go like this rather than moving like this. Okay, so I'll make it a bit more clear. The light ray, actually if there is no change in medium, what is that? It moves in a straight path. There is no bending or there is no curve. So what is our expected one? What is the expected one? Let's draw the normal alone so it's better for your understanding. So first we'll draw the normal and we'll draw the incident ray and the path which it has to be followed according to rectilinear propagation of light in red. Okay. So this is the points. This is the intersection point and this should go like this. Am I right? This is the incident ray. And if it was rectilinear propagation, it had to move like this. But due to the property of refraction, it would either move like this or it will move like this. Okay? This movement of either moving towards the normal or away from the normal is dependent on a quantity that is known as optical density. So, refraction or the angle of refraction depends on optical density. So, this is very important. According to this, there is two changes happening. What is that? Moving away from the normal and moving towards the normal. So, let's see how it is. What is the optical density, or like from moving from what optical density to what optical density will it move closer and moving away. So, before that, let's revise the definition for refraction. So, refraction means the bending of light ray from when it is moving from a medium to another. See, it moved from one medium to another, therefore there is a bend. Okay, that is what is refraction. So, to talk about optical density, there are two types. I'll write. There are two types of optical density. One is optically rarer medium and optically denser medium. So, rarer means it's optically less in quantity, and denser means it is more optically dense, or it is more optical density. So, what happens when light ray from a rarer medium moves to a denser medium? What happens? It moves towards the normal. Towards the normal in the sense, what happened? The angle will become small. So, what is happening? The angle would become small. So, the diagram would be what? Something that would look like this. If this is the normal, if it is going like this, it will move like this. Okay? This would be for what? Moving from rarer to denser medium. Okay? So, the second one is, that is, it is moving from denser to rarer medium. So, what happens? There would be moving away from the normal. Okay, this would be like this and this would move like this. So, this is the incident ray, this is the refracted ray, and this is the path it should have followed if it was rectilinear propagation. Okay, so what is that? We learned about rarer and denser medium. If it is moving from rarer to denser, what happens? It moves towards the normal, and it's moving from denser to rarer, it moves away from the normal. So, let me tell you why is this. Don't get confused with this, because I'll tell you. Let's take a container, or let's imagine you are moving through air. You can walk freely, but when moving from air to water, what happens? You can't walk easily through water, but in a situation or in a surrounding where there is air or vacuum, you can move easier. So what happens? Your speed is more. When your speed is more, what happens? You can run faster. Okay, when you run faster, you can move in any direction. But if you're going through a gluey, or you're going through some clayey material, if you have to walk through a clayey material, you wouldn't have much of a movement, but you would have to, keep a straight track. Okay, you can't run away like this on a clayey surface. In the same way, when you move from a rarer to denser, you cannot increase your speed, you have to decrease your speed. So what happens? There's a decrease in speed, there's a decrease in angle. So rarer to denser, decrease in speed, decrease in angle. From denser to rarer. Now you are tightly packed in a room and you just given away. Now it's lockdown. When the lockdown is removed, or when there is no COVID-19 issues, what would we do? We would run out to meet our friends. The same way, from a denser medium, it will move to a rarer medium. It will have a more wider path. Okay? So that is to talk about refraction. And in refraction also, we have two laws to learn. So let's see what are the two laws. So as we learned for our reflection, the first law remains the same. Then only a change in the second law. So let's see the very first law that we will discuss, and that is the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is a constant in a medium. Okay, so So what is that? Ratio of sine of angle of incidence is to ratio of sine of angle of refraction. So sine I divided by sine R is equal to a constant in a given medium. Okay, there's a condition, it's in a given medium. This constant changes with what, or it changes with the speed of light in the different mediums, or that is meant by the optical density in the different mediums, and also what, according to the different pair of media. If you take air and water, they would have a constant, constant as this ratio. Okay, everywhere you go or anywhere you go, everywhere you would have the same ratio. But if you take the same time air and honey, it would have a different ratio, but that would remain the same for like in any place if you test them. Okay, so that's the very first our law. And the second law, and the common law is the law which is similar to that of the law of reflection. So what is the law of reflection? The first law that we learned, that was the incident ray, the reflected ray and the normal all lie on the same plane. The same way for refraction, the incident ray, the reflected ray, the refracted ray and normal all lie on the same plane. Okay? Isn't that so? Because we drew, this is our normal, this is our incident ray, this is the refracted ray. Okay? All of them are on the same plane, are on the same 2D surface. This is our x-axis and this is our y-axis. This is on the same surface. Okay? So that is what is the laws of refraction. And the third one, or the third behavior we have to learn is the absorption. The fourth behavior is absorption of light. So, what do you mean by absorption? Let's see. So, you take a sponge. You say the sponge absorbs the water. What do you mean by a sponge absorb the water? That is, the sponge took inside or took in the water which was present outside. The same way absorption of light is the same thing. When a light encounters an interface, what happens? That light would be absorbed or would be taken in by the surface. See, if this is the light ray, this is our surface. What would happen? There would be no reflection or refraction. Instead, this light ray is being absorbed by this. Okay? This is called as absorption. So, what is absorption of light? Absorbing of a light ray that is falling on an interface. So, we learned about the three phenomena. Am I right? What were the three phenomena? Except rectilinear property is not actually a behavior, but that is a property that we have to learn. I just mentioned it because for all of this, you never drew the light ray to be like this. Was the light ray like this? Or was the light ray to be a circular coil or anything? No, it was always a straight line. So that I mentioned it with the behavior of light. Because light behaves that way. Okay? So, as told, this absorption, this reflection and refraction, actually in a real life, complete reflection or complete refraction or complete absorption is not taken place. Always what happens is, let's draw the diagram. Always what happens is a mix or it's a combination of all these three. This is reflection, this is refraction, and there is absorption also. So, all these three would happen. It's not alone reflection, not alone refraction, not alone absorption. All three happens in any situation. Because actually you see a substance, actually there is some other light ray falling on this. It is only black that is reflected back, and that is why you see the back of the duster to be black in color. Okay, so there is absorption of some colors of light as well as reflection of black, and there is maybe refraction of something, some light particles. We don't know. So let's say this is the conclusion that we have to learn about the the behavior of light in aura. So, let me conclude by stating one more law. Fermat's principle of least time. We have always heard about this. What is that? This is a principle that helps us to prove that rectilinear propagation of light is actually true. So, we'll prove that and then let's say a stop for today's session. So, Fermat's principle of least time. So what is that? We said, well, if it is to prove that rectilinear propagation, what is that? Light should travel in a straight line. So this principle says that light takes the shortest path possible, or it wants to travel as quick as possible. Let's take the light ray to be an ambulance. And see, here we have a spot. This is where the ambulance has arrived and taken the patient. And this is obviously our hospital, where the ambulance has to reach to save the life of the person. So, there are some paths for moving from one place to another. Okay? So, for example, there is a path like this. From here there is a path like this. There is a path like this. There is a path like this. Which would be the shortest path? That would be the displacement. That is, the shortest path would be the straight line between the 2 points. Am I right? Didn't we learn that in physics? What is the shortest path? That is the straight line joining 2 points is the shortest path. And hence, it will follow this straight line. Am I right? The same way, the ambulance in our case is the light. So, light would take the shortest path. And let's see. For example, let's take light travels to a point. Our ambulance. The same way our ambulance and the hospital. What would an ambulance do? It will take the shortest path. If there is a block in the shortest path, or if there is a traffic, okay, here there is a traffic. What would it do? It will take another path through which it can reach the ECS. The same way, light is also behaving in the same way. If there is an obstacle, it reflects, refracts and absorbs. That is the different nature of a light. So with this principle of Fermat's, we have found out, or we have proved that rectilinear propagation of light is true. Because what? The shortest distance between 2 points is obviously a straight line joining them. So what is that? Rectilinear propagation is proved. So I hope all of this is clear, and this is all for today's session. I hope you might have enjoyed it. If you've enjoyed it, give my video a huge thumbs up and also subscribe to my channel if you're new to it. And share my videos with your other friends. So see you on the second part of this chapter. Till then, bye-bye.